So warm good afternoon, students. This is Morgan, working as assistant professor for the Department of Mechanical Engineering in Erode Secondary Engineering College. And today we are going to discuss about the topic uh, which is coming in your second unit in your MT Manufacturing Technology 1. Okay, and it is metal joining process. And what is metal joining process? So metal joining process is, we saw about metal casting process in the previous unit. Okay, how the metal is being prepared, either in the form of block, in the form of rod, or anything. Okay. But in this topic, what we are going to do is the metal that has been already prepared has to be joined with the help of some medium. Okay, for that purpose, we are going in for welding. Okay, let us see what is welding is all about. Okay, so welding is the process of permanently joining two similar metals by the application of heat, pressure, and electricity. Okay, so either heat should be used, or pressure should be used, or electricity can be used. It is not necessary that all these three application is required for completing a welding process. Either heat and pressure may be used, or electricity or heat may be used. Okay, so it is dependent of, according to the type of welding process we are going to use. Okay, so it is a fabrication process that joining materials, usually metals or thermoplastic, by causing coalescence. Coalescence is nothing but the area where you are going to weld. That area has to be heated first. Okay, so once it is getting converted into recrystallization temperature, once it attains its recrystallization temperature, what happens is we are going to mix material one with material number two by application of pressure. Okay, so what happens? Material, consider that you have two plates like this. So one plate is like you have kept like this, and other plate is like this. Okay, you have to join these two plates. So what happens is you have to create the heat in this particular area. On the corners, you have to apply the heat. Okay, and that heat has to be maintained until it reaches the coalescence state. Coalescence state is nothing but it gets converted into red hot iron. Okay, and that is the stage where the welding can be completed. Okay, so it is noted that even dissimilar metals can also be joined with the help of welding process. There are some type of welding operation that is predominantly used for joining two dissimilar metals also. Okay, it is not necessary that only metals are being joined. I mean, similar metals are being joined with the help of welding. It is also possible to weld dissimilar metals also. Okay, so in the case of dissimilar metal, the metal joining process is carried out by application of heat and pressure alone. Okay, so heat and pressure alone. So what does it mean is you you do not require any other supporting tools in order to produce heat. Okay, just by rubbing two metals, what happens? The friction will get produced. Okay, the friction results in the development of heat, and by application of pressure, you can join the two similar or dissimilar metals. Okay. So in welding process, the base metal is taken to its plastic state by application of heat. Basically, the weld metal is stronger than the parent metal. Okay, what does it mean is in the welding process, say for example, you are considering two similar metals. Okay, so what should you do is first you have to heat the metal. Okay, up to its plastic state. The metal should lose its what to say, you lose its state from solid to it. It will get converted. It will start getting converted into liquid state. Okay, till that form, you have to apply the heat over the metal so that it can be easily coalescence. Coalescence is nothing but mixed. Okay, mixed with one another. Okay, but it normally affects the metallurgical property of the metal because of heat affected zone. Okay, this particular point has to be noted very well. Okay, heat affected zone is quite important in the case of welding process. So what happens is the metal will also will again undergo heat treatment process. Okay, so that heat treatment should not affect the metallurgical property of the metal. Okay, but what happens is, and the welding area alone will get uh, what to say, will get an enhanced property, whereas other areas will be considered as heat affected zone, so that there the material property may be a different one. Okay, let us see the classifications of welding in the next slide. So we have the different classification of welding process over here. So we have the first thing is gas welding process, and under gas welding we have air acetylene, oxyacetylene, oxyhydrogen, and pressure gas. Okay, So these are the various types of gas welding that you are going to see in this particular unit. And coming to the arc welding we have carbon arc welding, next submerged metal arc welding, and submerged arc welding is there. Then GTAW is TIG welding. Okay, the other name for it is called as gas tungsten arc welding. The other name for it is TIG welding. Okay, we will call it as tungsten inert gas welding. And MIG welding is metal inert gas welding. And we have electroslag welding, and finally plasma arc welding. These are the welding methods that are coming under arc welding process. Okay, the next thing is resistance welding. In resistance welding, we have spot welding, then seam welding we have, then projection welding is there, flash butt welding is there, and resistance welding we have, resistance butt is there, then high frequency resistance and protrusion welding is there. Okay, so these types of welding are coming under your resistance welding category. And the next stage is solid state welding. So this particular welding process is especially meant for joining two dissimilar metals. Okay, before that we've seen about gas welding, arc welding, and resistance welding. In these types of welding, we will be joining two similar metals. The metals will be of similar kind. So piece one is of MS means piece two also should be MS, and your electrode or filler metal should also be of the parent metal. Okay, that is in the case of gas welding, arc welding, and resistance welding. And coming to the solid state welding, it is not necessary that the two metals should be of same kind. Okay, there are this metal may be of your mild steel, and this can be your stainless steel or say any other medium. Okay, either copper or something. Okay, the only thing is by applying what are they applying friction, we are obtaining the heat, and after that by application of force we can join these two metals together. Okay, and the welding process will be getting completed. Okay, in the solid state welding, we are not going to heat the metal. Okay, I mean we are not going to apply heat over the metal. Okay, the next thing is we have cold welding, then explosive welding we have, and friction welding is there, roll welding, diffusion, forge, hot pressure, and ultrasonic welding. Ultrasonic welding is somewhat different from any other methods, because here we are going to use ultrasonic sound in order to make the welding. Okay, so this particular ultrasonic welding is responsible, I mean this particular is predominantly meant for joining plastic material. Okay, it is meant for joining plastic material. And we have thermochemical welding is there, we have thermite welding and atomic hydrogen welding. Okay, thermite welding, what is the type of thermite welding is we will be using in the case of laying railroads and all, right? We have railroads, it is not continuous, you have to weld the two railroads together. Okay, so for that type of welding, we predominantly use our thermal electro welding, which is called as thermal welding also. Okay, and we have radiant energy welding, and under that we have electron beam welding and laser beam welding. Okay, and in this particular topic, in unit 2, what are the types of welding you are going to see is listed here. Here we have the classification of welding again. So in gas welding, we have acetylene, air acetylene welding, oxyacetylene welding, oxyhydrogen welding we have. And coming to arc welding, we have carbon arc welding, plasma arc welding, shielded metal arc welding, SMAW, TIG. TIG is also called as gas tungsten arc welding. Okay, it can be also called as GTAW welding. And we have MIG welding, submerged arc welding, electroslag welding we have under the arc welding process. And coming to the next process, we have resistance welding. Under resistance welding, we have spot, seam, projection, resistance butt, flash butt, and percussion welding. And in the case of solid state welding, we have forge welding, explosive welding, friction welding, and ultrasonic welding. And thermochemical welding, we have thermite welding. And radiant energy welding, and we have electron beam welding and laser beam welding. These topics will be covered in this particular unit. Okay, so we have other than this, we have some other methods, that is advanced methods also we have. But this is the basic thing that we are going to see in this particular unit. That is unit number 2, metal joining process. Okay, let us move on to the next slide. So we have gas welding here. So here we have a typical diagram over here. We have two cylinders which contain the gas we have, and also on the left hand side of the diagram you can see some workpiece over there. Okay, the workpiece is differentiated in these two colors of shades of gray. One is the light shade, and we have another dark shade. And it doesn't mean that we are joining two dissimilar metals. Okay, gas welding is predominantly meant for joining two similar metals. Okay, let us see what are the points given over here. So in this type of welding, the oxygen, hydrogen, or oxyacetylene gas is burnt in a torch to create a pointed flame. Okay, so these two gases have been mixed together. Okay, let us see what is happening. I'll just explain the points alone first, and then we will get into elaboration. Okay, so next point is this flame in turn creates heat in the adjoining parts of the joint metal. Okay, so you can see here a red color indication is there. So this is where the coalescence is getting created. Okay, how the coalescence is getting created? We are targeting this flame over that particular area, that is the adjacent area over here. So what happens, that particular area is alone getting heated up. Okay, it is here they are not they have not mentioned about the filler metal. I'll say what is filler metal is all about. Okay, we'll be seeing in the next slide. Okay, then a filler metal or welding rod is melted and allowed to sediment over the gap between the two metals. Okay, so you can see uh, even if you are holding it very in a very rigid manner, you can see some gap. You can see some gap in this particular area. So welding is nothing but you are going to fill this gap with the help of the same metal. Okay, so for example, this is metal number one, and this is metal number two. So both is of same kind. Both is of same kind means this is also ms plate and this is also mild steel plate. Okay, so what happens if you are adding some other material? Okay, for example, if you are adding aluminum to this, what happens? It will not create a homogeneous bond. Okay, it will not create a homogeneous bond since the material is different from parent material. So what happens? Your filler metal should also be of what? It should also be of the same kind. Okay, that care should be taken. Okay, let us elaborate this diagram so that I'll just expand this diagram so that you can see it very clearly. So, so see, so we have two different cylinders over here. So one is meant for oxygen cylinder and the other is for acetylene cylinder. Okay, oxygen is stored in the black cylinder and acetylene gas is stored in the maroon cylinder over here. Okay, so you can see that you have two regulators over here. Okay, you can see two regulators. So that is indicated in this blue color indication is there. Okay, so that is the pressure regulator. So I'll just say what are the things available here, and then we will be discussing about what are the applications of that particular uh, parts. Okay. Then we have your pressure regulator, pressure gauge is there. So pressure gauge indicates the pressure, how much pressure, or how much working pressure is maintained over here. That can be indicated with the help of this pressure gauge. Okay. And we have the hoses. Hoses also is of the same color. Okay. So if it is oxygen cylinder, the hose will be black, and if it is acetylene cylinder, we have maroon color cylinder. Okay. And also we have a nozzle over here. We have a nozzle. Here we have a welding torch over here. So this is called the mixing area. Okay, this is where oxygen and acetylene gas is getting mixed. Okay, so here oxygen and acetylene gas is getting mixed, and through the nozzle, these two gases are combined together and coming out of it. Okay, for initial ignition, we will be having a what to say, we will be having a lighter or something in order to ignite this particular gas. Okay, can you see? So we have two cylinders and we have two pressure regulators are there, and we have four pressure gauges. Okay, so we have four pressure gauges. We have what to say, gas hose we have, and we have a welding torch, and finally we have a nozzle. Okay, so let us see why two regulators are being present in this cylinder. So regulators controls the pressure of the working gas. Okay, so gas should be controlled. So if you open we will be also seeing about the flame characteristics in the case of gas welding process. Okay, so in that for that purpose we will be controlling the pressure with the help of the pressure regulating valve. Okay, this is called as the pressure regulating valve. Okay, so the pressure has to be maintained as such, the requirement as per the requirement. And we have four different gauges over here. Okay, two is meant for oxygen cylinder and other two is for acetylene cylinder. Okay, so what does these two regulators do here? Okay, so one shows, one represents the working pressure. Working pressure is the gas that is leaving outside the cylinder. That pressure will be shown with the help of one pressure gauge, and the pressure within the cylinder, the pressure inside the cylinder, what pressure is maintained inside the cylinder, that can be noted from other gauge. Okay, and that is why we have four different gauges over here, two cylinder each. I mean two gauges in each cylinder. Okay, one is for maintaining the working pressure, and other is for noting down the gas pressure. Okay, so can you understand what I'm saying? Okay. So let us move on to the next slide. Uh, so actually, this is the oxyacetylene arrangement that you can find over here. So here you can see the mixture of acetylene gas and oxygen gas is entering to the nozzle, and here you can see this is the flame, and you can see some additional spark is being produced here. Okay, this spark is what we can say is, we'll call it as shielding gas. Okay, this particular area where you are making the welding has to be protected from atmospheric interaction. Okay, so in case if there is an atmospheric interaction, or there is a presence of oxygen, what happens? The molten metal will start creating bubbles. Okay, so this is the filler rod. So what we are doing is, here the flame is being applied. I mean, flame is being coming out, and here you are introducing the filler rod onto this flame. So what happens? The filler rod will get converted into liquid state, and after that, this sedimentation will happen in the form of liquid. Okay, so what happens if there is no proper shielding provided here? There is a possibility for atmospheric interaction in this particular area, and that creates bubbles. Okay, that creates molten metal to carry bubbles over it. So what happens? After some time, the bubbles will start breaking. Okay, so the bubbles will explode, resulting in pores. Okay, resulting in pores. There will be a small pores left over on the weldment. Okay, that doesn't create a good impact on the welding. Okay, that should be completely eliminated, and that is why we are using a shielding gas also. Okay. So, and we have a flame over here, and you can see the travel direction. They are providing a travel direction in which direction the filler rod is being moved. Okay, so this is the typical diagram of gas welding process here, from which gas is coming out, and in this particular area, we are igniting the gas. The gas produces the flame, and the filler metal is being introduced to that flame so that it will get heated up and it will get converted into liquid form that will be sedimented over the base metal. Okay, can you understand? Okay, let us move on to the next slide. And we have two different techniques in glass welding process, and that is rightward or forward technique, and leftward or forward technique, and rightward or backward technique. Okay, this determines the movement of the welding rod and also your torch. Okay, on the right hand side, I have shown you with the help of diagram. Okay, so here you can see, just I'll make it the screen, make it to full screen. So you can see what are the points available over here. So on the leftward or forward technique, we have welding is done from right to left. Okay, the welding starts from right to left, and you can see some points given over here. So this is the torch we have, and we have a weld metal here, and no protection from atmospheric oxidation. So you can see there is no protection from atmospheric oxidation reaction. So oxidation reaction results in pores, formation of pores that cannot be eliminated in the case of your leftward or forward welding process. Okay, so let us discuss the points here. So welding is done from right to left. You can see the movement of the welding is from right to leftward. Okay, then the torch is held in the right hand. So you have to hold your torch in your right hand and the filler metal in the left hand. Okay, so the torch should be moved sideways but not the filler metal. So this represents only the torch should have the axial movement, whereas your filler metal should be held in a rigid manner. Okay, the filler metal should not be moved. Okay, only the torch has to be moved on either sides in axial direction. Okay, so they have also provided the angle in which the torch and the filler rod have to be held. Okay, the filler rod held angle is 30 to 40 degree. They have the angle has to be maintained between 30 to 40 degree, whereas torch angle is provided from 60 to 70 degree. So the torch angle will become in between 60 to 70 degree. Okay, let us see what they have said in rightward or backward technique. It's just the vice versa of your leftward technique. Okay, so the direction of movement is from there it is from right to left. So here it is from left to right. Okay, there is no change in holding the filler rod and torch. Okay, which means that here we have seen that torch is held in the right hand. The same thing is happening here. You are holding the torch in your right hand and your filler metal in the left hand only, but only the angle is different. Okay, and filler rod angle is similar to that of your leftward technique, and torch angle is quite minimum. Okay, it is in the case of leftward techniques, we maintain the torch angle between 60 to 70 degrees, whereas here in your rightward or backward technique, we are maintaining it in 40 to 50 degrees. Okay, so hope you understand the diagram. And coming to the flame characteristic, okay, we have three different flames over here. So we'll call it as neutral flame. Then we have acetylene flame and also your uh, oxidizing flame. Okay, so we have neutral flame, carburizing flame, and oxidizing flame. Neutral flame is nothing but we will be supplying the same amount of. We are going to use only oxygen and acetylene gas over here. Okay, but what proportion of gas is being let out? Okay, what proportion of gas is being used here that has to be maintained. This depends on the material that you are going to join. Okay, for example, if you are joining steel, the gas amount of gas will be changing accordingly. Okay, so let us see what are the different types of uh, flame available in the case of gas welding. So first thing is your neutral flame. Next is your carburizing flame, and we also have acetylene flame. Okay, your oxidizing flame. Okay, so let us discuss about the neutral flame. As the name indicates, here we have same amount of oxygen and acetylene used in this particular flame characteristic. Okay, so we in this topic we have two different cones available over here. One is the outer cone and other one is the inner cone. So inner cone is the temperature is given here. It should be maintained at 3300 degrees Celsius, and the outer envelope it is quite lesser when compared to the inner envelope. It is maintained at 1260 degrees Celsius. Okay, the inner cone here you can see the inner cone produces heat and the outer cone produces protects the molten metal from oxidation reaction. So what happens? The inner cone produces heat. So what happens? This flame is responsible for converting the filler metal into a molten metal. Okay. So what are the outer flame? What are the use of outer flame is in order to protect the weldment. Weldment is nothing but the welding area from atmospheric interaction. Okay. So if you are using this type of flame, what can be done? Okay, that you can see over here. The flame is blue in color and used for welding stainless steel, cast iron, copper, and aluminum. Okay, this particular flame is used only for welding this type of material. So we have stainless steel, cast iron, copper, and aluminum. Okay, so we will move on to the next point. Inner cone, the temperature is being given over here also. Okay, so it is from 3040 degrees Celsius to 3300 degrees Celsius, and the outer cone is 1260 degrees to 2100 degrees Celsius. And the reaction of inner cone is uh, the chemical reaction has been given here. Okay, so here we are providing acetylene gas, which gives out carbon dioxide plus heat. H2 is heat. Okay, the reaction of outer cone is also given here. Okay, so coming to the next topic, we have carburizing flame. Carburizing flame is we are providing higher amount of acetylene gas when compared to that of oxygen gas. So higher amount of acetylene gas is being produced here, and we can see three zones are available here. So we can see in this particular diagram, you can see only two difference in color. Okay, one is red color and another one is blue color, and it represents that is there is only two flames present in this particular flame gas. Whereas in this particular flame, we have three different colors. One is yellow, red, and blue. Okay, so there is three zones of what are they flames available in this area. Okay, so we have three zones in inner zone, outer zone, and the intermediate zone. The inner cone is bright white in color, and the intermediate cone is red in color, and the outer cone is blue in color. Okay, so this cone, the appearance of this cone is because of we are providing higher amount of carbon, a higher amount of acetylene over here, and that is why we have produced three different types of flames. Okay, can you understand? So let us move on to the next point. Inner cone temperature is being provided, and mixing ratio is given over here. So we have oxygen, and oxygen is to acetylene. What the ratio is? We are providing lesser amount of oxygen, that is from 0.85, whereas acetylene is 0.95. Okay, and that is why we have three different flame over here. The next thing is the oxidation flame. Oxidation flame is nothing but higher amount of oxygen is getting supplied to the nozzle. Okay, similar to that of neutral flame. Inner cone is purple in color and the outer is blue in color. Okay. So and also I have given the sorry. Also I have given the mixing ratio over here, oxygen and acetylene. Here oxygen is 1.5 parts of oxygen is provided, whereas 1.15 parts of acetylene is only provided in the case of oxidation state. Okay. So let us move on to the next thing. So next thing we have arc welding. So gas welding is completed now. Okay. We are well aware of gas welding now. Now let us move on to the next topic. We have arc welding. Okay. Let us see what are the first we will discuss what are the points available over here, and then we will talk about the diagram. Okay. We can also speak some other points related to this diagram. Okay. So we have arc welding process. In this process, in which an electric arc between an electrode and the workpiece is utilized to weld base metal, is called as an arc welding process. Okay, so you are using the electric current over here. So in your previous thing, you are not using electric current, only heat is being used. Okay, how the heat is being produced with the help of gas welding process, we are going to burning the two gas so that the heat is being produced. Whereas in this particular welding, we are using electrical energy. Okay, so that is why we will call it as arc welding process. Okay, let us see the first point again. The process in which an electric arc between an electrode and a workpiece is utilized to weld base metal is called as an arc welding process. Here, a new term has been introduced that is called as an electrode. So, electrode is nothing but a charge carrying conductor. Okay, so that has to be noted down here. Okay, so in the previous thing, in the case of gas welding, we were talking about filler metal. Okay, so filler metal is considered to be the bare electrode. Okay, we call it as electrode, we can call it as electrode also, but it is considered as bare electrode. Whereas in this electrode, I mean, that in the case of arc welding, we will be using an electrode which is completely covered with the help of flux. We will be having a flux coating over the this one filler metal. Okay, so this is considered to be electrode, whereas in your gas welding, that is said to be a barrel. Okay, so in most of these processes, use some shielding gas, while others employ coatings or flux to prevent the weld pool from the surrounding atmosphere. Now, can you understand why electrode is surrounded by flux? Okay, the flux coating is provided in order to prevent the weld pool from the surrounding atmosphere. The same thing. Okay, in gas welding, we use the gas in order to one gas is meant for heating the base metal, and other gas is being utilized as a shielding gas. Okay, the same thing is happening here. Okay, by the use of flux. So flux coating provides the what to say shielding area that prevents the atmospheric interaction into the weld. Okay, so here we can use both direct and also alternating current for electric arc welding. Okay, each having its particular application. Yeah, DC weld supply is usually obtained from generators given by electric motors, or if no electricity is available, internal combustion engine can be also used in the case of your arc welding process. For for AC welding supply, transformers are predominantly used for almost all arc welding where main electric power supply is available. Okay, wherever the electric power supply is available, you can use alternative current for all which has been used predominantly in all type of arc welding process. Okay, then we have step down transformer also, which can convert 200 volts to 400 volts normal open circuit welding voltage, 50 to 90 volts and 50 to 250 amps also. The amps can be changed according to the thickness of the plate. Okay, according to the thickness of the plate, the amps have to be reduced or increased. Okay, so here we have the typical diagram of your arc welding process. Let us discuss what are the parts available in this particular diagram. So you have a metal droplets, which means the metal is getting converted into liquid form and it is being sedimented over the base metal. Okay, and we have an electrode coating. Here you can see a slight mesh-like appearance over here. So this is your base metal, which is completely white in color, whereas here you can see some hatches given over here. Okay, this hatches represents the coating. So what kind of coating is provided here? It will be provided with a flux coating. So flux, what are the use of flux over here? It provides what? It provides shielding to the weldment. Okay, shielding to the weldment. Why shielding has to be done? The atmospheric interaction has to be completely eliminated. Okay, that is why we are using coating that is called as flux coating. Okay, then we have a protective gas from electrode coating. we have as this flux burn, what happens? The gas is being produced, which protects the weldment from the atmospheric interaction. And here you can see molten weld. Okay, here you can see the molten weld. You can see the difference in hatches over here. Here we have hatches which is running from right left, where here it is from left to right. Okay, so this is the new formation. Okay, this is the sedimentation, and this is your basement. Okay, can you identify the difference over here? The difference in hatches. So this type of hatches represents your new sedimentation, whereas this is your older one. Okay, and we also note that the slag is being present over here. So what happened? This burnt flux is being sedimented on over the top of the weldment. Okay, this burnt gas. I'll just say you what happens here. So this thing electrode is also getting melted up. It's also getting burnt up with the electrode also. Okay, with the electrode it also gets melted up. So what happens? The density of the molten metal is higher than that of the density of your flux coating, and that is why the molten metal goes inside, whereas your slag, the formation of slag is being present over the top. Okay, since the density of your flux is quite minimum than that of your metal, the slag is being present over the top. Okay, can you understand with the help of the diagram? Let us move on to the next slide. Yeah. So next topic we have tungsten inert gas welding. Okay, this is also comes under inert gas welding, and here we will be using a actually electrode. In the case of electrode, we have two types of electrode. One is your bare electrode, and one is your flux coated electrode. And in addition to that, we have other two difference. What is that is we'll be having a what to say, your sacrificial electrode or non-sacrificial electrode. In other words, we will call it as consumable electrode and non-consumable electrode. Okay. Whereas in the previous topics, wherever you saw, we were talking about filler metal, right? There and all, we will be using your consumable electrode. Whereas TIG welding, this is the first type of welding we are using a non-consumable electrode, which means that the electrode will not get melted up. Okay. Here also, the electrode is responsible for producing heat, whereas that heat, what due to the interaction of heat with the other metal, what happens? The other metal will get melted up. So, as the name indicates, here we are going to use a non-consumable electrode, which is made of tungsten element. Okay, we'll be using tungsten element over here, which is a what to say, which withstands higher amount of temperature. Okay, so you can also called as this process can be also called as gas tension arc welding. Okay, this is also called as gas tension arc welding. So you can see that electrode arc is produced between the workpiece and the electrode. So in the previous diagram also, you can see that there is no interaction between the metal, I mean the base metal and your electrode. Why? So care should be taken here, because only if the gap is maintained, okay, only if the gap is maintained between the electrode and the workpiece, the spark will get produced. Okay, the spark will get, I mean, the arc will get produced in the case of arc welding. So for initial contact, for initial spark production, what you have to do is you have to bring the electrode in contact with the metal, and once the spark gets developed, what you have to do, you have to maintain a particular gap, that is from 1 mm to 3 mm gap has to be maintained, and that gap is said to be the arc gap. Okay, in the case of arc welding, in any case of arc welding, the arc gap has to be maintained, which lies between 1 mm to 3 mm. Okay, care should be taken there also. Okay, so you can see the next point. The oxides of thorium and zirconium help the electrode to maintain its shape and the tip for a longer time. Okay, so since we are using tungsten element, tungsten will also get heated up. On continuous heating, what happens? It also starts melting. Okay, so in order to avoid melting, what happens is the oxides of thorium and zirconium is being used, is being coated over the tungsten. Okay, for a prolonged lifetime. So what the tungsten filament carries with it is uh, coating of thorium and zirconium is being available. Okay. Next point is, while supplying the electric power between the electrode and the workpiece, the inert gas is passed through the nozzle through the electrode. So we'll see the diagrammatic explanation also in the next slide. So before that, we'll discuss this point. The inert gas acts as a chilling gas that prevents the atmospheric effect on the well. So here what happens is, here gas is also being introduced. So this tungsten inert gas welding combines both the applications of arc welding and also gas welding. So here uh, gas is used for stopping the atmospheric interaction, for shielding the atmospheric interaction in order to provide a better welding. Okay, so filler metal is used in order to fill the gap between the plates. Here, the filler metal is used. So, see, we are using a tungsten electrode. So, tungsten electrode is considered to be the non-consumable electrode. So, we are using a filler gap here. I mean, filler metal here. Okay, the tungsten electrode has the highest melting point of 3430 degrees Celsius, and that it won't melt. Okay, so for on continuous heating, it may also melt. Okay, for that difficulty, for in order to overcome that problem, what it has been done is we are coating it with thorium and zirconium powders. Okay, so next point is the inner gas may be either helium, argon, nitrogen, or carbon dioxide. So these are the inner gases that have been used in this particular TIG welding process. Okay? So TIG welding is used for welding steel, aluminum, cast iron, magnesium, and stainless steel. So this much material can be welded, can be joined with the help of TIG welding process. Okay. So next one is suitable for welding plates of thickness less than 6.5 mm. Okay, the thickness of the weldment should be less than 6.5 mm. So let us see what is the things available over here. So as I said, it is a combination of arc welding and also gas welding. Okay, so here you can see the arc is being produced over here by the application of electric current, whereas in order to provide shielding to the gas, what we are going shielding to the weldment, what we are going to use is we are using gas. So what are the gases we are using here? So here you can see we have used helium, argon, nitrogen, or carbon dioxide. Either of these gases can be used in order to complete the welding operation. So let us see what is the things are available here. So as I discussed, in your gas welding process, we have a regulator and we have a pressure gauge also. So working pressure is being monitored with the help of your gas pressure. Okay, and we have in order to what to say, in order to charge this gas, what we have a particular charger over here, and in this electrode is connected to the electric power supply. Okay, the tungsten electrode, here you can see the tungsten electrode is present over here, and only there is no continuous reel is being there is no continuous supply of tungsten over here. So this, which means that the tungsten is considered to be the non-consumable electrode. And here you can see a TIG filler rod. Okay, you can see a filler rod over here. This rod gets melted up and gets sedimented over the workpiece. That you can see over here. Okay, so let us see the arrangement again. So here you can see the inert gas in order to supply the inert gas, you have a small projection over the what to say, the welding gun. We'll call it as a welding gun, which carries the electrode, which is connected to the positive terminal or the negative terminal, and the workpiece is connected to another terminal of the welding power source. Okay, so can you see? So gas is also coming here, and also due to the electric current, what happens? This tungsten electrode is getting heated up, and that heat is supplied to the filler rod. And what happens? The filler rod will not withstand the heat, so that is why it is getting converted into liquid form and is getting sedimented over this area. So can you understand what stick welding is about? Right? Let us move on to the next thing. We'll have the metal inert gas welding, or we will call it as MIG welding. Okay, it is otherwise called as gas metal arc welding. We will call it as GMAW welding. Okay, GMAW welding. Okay, so electrical arc is produced between the workpiece and the electrode. It is same as that of the previous thing. Okay, electrical arc has to be produced between your electrode and the workpiece. Okay, the electrode holds a consumable metal wire electrode which is continuously fed from a reel feed unit. So here you can see the absence of reel feed mechanism here. Okay, since the tungsten electrode is a non-consumable electrode, we are using a filler rod over here, where in this particular diagram you can see the absence of filler rod, but there is a presence of wire reel for continuous feeding of electrode. Okay, so let us see what are the points available. So electrode holder holds a consumable metal wire electrode which is continuously fed from the reel feed unit. So the electrode is being continuously fed from the real feed unit. Okay. The next point is the welding torch consists of a press button. When pressed, it feeds the metal electrode wire for welding. So it is provided with a button, which when you are pressing the button, what happens? The welding torch will provide you the consumable electrode continuously. Okay, the welding electrode has the same chemical composition as that of the parent metal. Okay, can you understand? Here also we are joining two similar metals only. Okay, but in the case of TIG welding, we will be using filler metal, whereas here the filler metal is being absent. Rather than using a filler metal, here they are using a continuous metal electrode, which is also the same kind of your base metal. Okay. Next, the inert gas acts as a shielding gas, same as that of your TIG welding also. The fused metal electrode is supplied over the surface of the workpiece, and DC generator and AC transformer is being used here in the case of MIG welding. And the inert gas may either be helium, argon, nitrogen, or CO2. The same kind of inert gas is being used in the case of MIG welding also. The current range is from 100 amps to 400 amps. This also it may differ as per the uh, thickness of the metal that has been joined. The welding torch may be either air or water cooled depending upon the current used. So you can see over here in this image also, there is since the tungsten electrode is getting heated up continuously, there may be a water jackets available in this particular area. So yeah, in order to cool down the temperature of your tungsten filament, I mean tungsten electrode, you will be using cooling jackets in order to bring the temperature down. Okay, the same thing is also available in the case of MIG welding also. Okay, so most of the things are similar when compared to that of your TIG welding. The only difference is here we'll be having a real field unit which continuously fed your consumable electrode to the electrode holder. Okay, so it is quite similar in construction. We have a power supply positive terminal is connected to your electrode holder, and the negative terminal is connected to your workpiece. And you can see here also the supply of gas is present from the shielding gas cylinder. So you can see the pressure regulator available, pressure gauge is available, and the gas is sent to this particular nozzle area where uh, um, where we have two openings. One is for your electrode and another is for your shielding gas to come. Okay, the shielding gas protects the weldment from the atmospheric interaction. The same thing. Okay, the only difference is we are using a wire feed unit over here. Wired electrode feed unit is over here. Okay, while in the case of TIG welding, it will be provided with filler rod. Okay, can you understand? Okay. So next is your submerged arc welding. Okay, this is a typical welding process, and it is quite often used in the case of underwater welding. I mean, underground welding also. For underground pipelines and all, they will be using this type of welding. Okay. So let us discuss the points available over here. Flux around the electrode is meant for avoiding oxidation reaction due to atmospheric action. So this is quite known. Okay, since we have seen this in your previous all the topics that we have covered in this particular session, we are talking about flux coating. Okay, so why flux coating is used in order to uh, reduce the atmospheric interaction. Okay, so shielding gas also similar thing. In order to reduce the atmospheric reaction, what we are going to do is you can either use flux or shielding gas. Okay, so let us see what are the fluxes being used. If the flux lime, silica, calcium fluoride, and magnesium oxide. These are the various types of flux used here. Is along with the filler metal, then the oxidation reaction cannot be completely eliminated. So the flux should be supplied with the help of separate means. Okay, so can you understand? They say that if the flux coating is given to the electrode directly, okay, if the flux coating is given to the electrode directly, there is a possibility of atmospheric interaction to happen during your welding. Okay, so that has to be eliminated. Okay, so for that purpose, what they are doing is they are not covering your electrode with the help of flux. I mean, they are not coating your electrode with the help of flux. Rather than using a electrode coating, they are supplying the flux in a large amount with the help of a hopper. Okay. So this method of welding is also called as hidden arc welding. It is also called as hidden arc welding, where your arc is completely hidden under your flux. Okay. I'll show you the image also. Okay. In this type of welding, the electrical arc is produced between the consumable valve electrode and the workpiece. The same thing happening here in the case of arc welding or I mean, in the case of your TIG welding and MIG welding, the same thing is happening here. You are maintaining a particular gap that is called as an R gap between your electrode and the work. Workpiece. Okay, the metal electrode is continuously fed from the reel by a moving head. Okay, here we have a moving head. It is quite similar to that of your MIG welding process where the wire reel is available. The same thing is happening here also. Since the arc is completely covered, there won't be any defect in the welding. So this type of welding is completely defect free. There won't be any appearance of spores on the outer surface on the weld area. Okay, so that is why they are predominantly using this type of welding under in the case of underground pipeline welding. Okay, it carries some it may carry some acid or it may carry some water. The leakage has to be completely eliminated, right? So for that purpose, for that assurance, they are using submerged arc welding in the case of welding your underwater pipeline. Okay, so let us see the other point. The flux not only acts as a protector, but it also serves as a deoxidizer or scavenger. Deoxidizer or scavenger is nothing but it is a poor reactor to your oxidation reaction. Okay, it completely eradicates the oxidation reaction in this particular welding method. Some of the flux melts and forms slag over the weld, and the unused flux is sucked back with the help of your vacuum system. So you can see only some amount of flux is being used during the welding operation. Since the flux is supplied in a greater amount, only small amount of flux is being used uh, when the welding is happening. Okay, so other flux can be sucked back and it can be reused with the help of your vacuum system. The vacuum system is provided which sucks the flux back, and the same flux can be the burn flux has to be removed. The burn flux will stick on to the welding due to the heat. Okay, so what happens? The unburned flux can be sucked back with the help of a vacuum system, and this process is used for welding low carbon steel, bronze, nickel, and other non-ferrous materials also. This is capable of welding non-ferrous materials also. And the voltage range is given here. The voltage range is from 25 volt to 40 volt. The current range is also given here. It ranges from 600 to 1000 AC or DC current, and restricted to flat surface. It is restricted to flat surface. And here the what to say? Here the advancement has also been come in this present day. Okay, they have also created a rotating table also in order to do a continuous welding on the surface of the your cylinder or something. Okay, so it is not, this point can be eliminated. Okay, it is not restricted to flat surfaces. The advancement has been made now. Okay, so carbon steel and alloy steel can be welded, and it is predominantly used for welding carbon steel and alloy steel. And plate thickness ranges from, you can see, 12 mm to 50 mm. What? So you will see this is capable of welding the plate with a thickness of 12 mm to 50 mm. Okay, so this is the typical diagram of your submerged arc welding. You can see AC or DC power supply is connected to your pillar rod, and this is connected to the feed unit, and you have a hopper over here which continuously supplies your flux from the hopper. Okay, so you can see here the material, I mean the metal is being melted and it is sedimented over this area, and here you can see the burnt flux forming a slag in this area. So you can see here solidified fused flux. Okay, you can see here the solidified fused flux is covering the area of the belt. Okay, so this is and you can see some dots over here which represent your unused flux. Okay, this is called as unfused flux. This can be sucked back with the help of your sucked back with the help of your this one vacuum. Okay, so with this we will complete today's class. Let us discuss the next thing in your uh, next class. Okay, we have other multiple types of welding process available in this particular business. We'll be discussing it in your later class. Okay, thank you for attending the class.